In this video, we are going to do classification of matrices. Now, first, based on the order, we can have a square matrix or a rectangular matrix. Well, it is easy to identify what is a square matrix. As you can see here, I've taken two square matrices, right? The first one, let's first understand what is a square matrix. So square matrix is what? Which has the same number of rows and columns. As you can see, the first one that I have taken, let's say A11. And you can see it has how many? It has two rows and two columns, right? A21 and that's A22, right? So this is a square matrix of the order 2. Now, similarly, what you can see here that this matrix have how many? 3 rows and 3 columns, right? So this is a square matrix. Now, coming to the rectangular matrix, if it has different number of rows and columns, so like this one, it has how many? 3 rows and 2 columns. This has 2 rows and 3 columns. Well, this has is a rectangular matrix. As you can see, it has 1 row and 3 columns, and this has 3 rows and 1 column. Well, this can also be categorized as this can be also be called as column matrix, right? So a matrix which has 1 column and any number of rows can be called as a column matrix. Sorry, row matrix. I was wrong. The one which is having only 1 row but any number of columns will be called as row matrix, as ROW. And this one should be called as what? Column matrix, because it has 1 column and any number of rows it can have. Now further we can see that there is a called diagonal matrix, which is nothing but a type of square matrix. So what is a diagonal matrix? So you should understand the diagonal matrix. If I talk about the diagonal matrix, you should know that the definition says that a square matrix whose all elements except the diagonal elements are zeros is called a diagonal matrix. So look into this. I have taken a look into this matrix. I'm taking this one. Here what I'm going to do is to, as you can see that it is a type of square matrix, and here all the elements except for the diagonal matrix are zeros. So I can say that the non-diagonal elements are what? Here that is 0. You can see that this is again a non-diagonal. This is non-diagonal, and this is non-diagonal, and this is non-diagonal. This is non-diagonal. So you can see that the non-diagonal elements are what? 0 in this case. You see, these are non-diagonal. Well, the diagonal elements can be anything. It can be any valid, can be symbol. I can place A, B, C. I can place a number along with this. This is what? A diagonal matrix. So one more time. So a square matrix whose all elements except for the diagonal elements are 0 is called a diagonal matrix. Now, the diagonal matrix can be also like a scalar matrix is what I'm talking about. So we can see from here the scalar matrix is a type of diagonal matrix, or you may say it is also a type of square matrix. But as you can see that the flow chart goes like this, from the square matrix, diagonal matrix is derived, and from diagonal matrix, a scalar matrix is derived. So what you can say about the scalar matrix, so if you talk about the scalar matrix, it says is a type of diagonal matrix whose all diagonal elements are same, non-zero, is called a scalar matrix. Now check here, this is a diagonal matrix. Reason is non-diagonal elements are 0, but as you can see that these elements are not same, right? It has to be same, non-zero. So therefore, we have to replace it with one such number. Like over here, what you can see, I'm going to write 3 over here. Everywhere I'm writing 3. So instead of 3, you can replace this with k or any other scalar quantity. So this is what? A scalar matrix. Now coming to the next, from the flowchart, you can further see that there is a unit matrix. Now you can see from here that the unit matrix have been derived from the scalar matrix. So let's check what is a unit matrix. So you look into the definition of the unit matrix. This is what is the definition. So what does it says? If you read, it says that a diagonal matrix in which all diagonal elements are 1 and non-diagonal elements are 0. Well, it has to be, because you can see that a unit matrix have been derived from a scalar matrix. And we know that in a scalar matrix, all non-diagonal elements are zeros and the diagonal element is a constant, same constant. But if I replace this, if I replace the diagonal elements with the number 1, then we say that it is a unit matrix. So if I going to replace it, let's say if I write this as 1, this also 1, and this also 1. Now we'll say that this is a unit matrix, but then it's a unit matrix of the order 3. So there can be unit matrix of other orders, like say if I change this one, right? Let's say if I this is of let me type one more. If I type one more over here, I have to modify this only. Let's say if I write 1 over here, this is a non-diagonal element, so it should be 0. This is a diagonal element, has to be 1. And this is a non-diagonal element, will be what? 0. Now we can see that this one is an example of a unit matrix of the order 2. So it's 2 by 2 by 2. Right. So we have come to this thing, right? And there are one more type. So based on the elements, there can be a null matrix. So what is a null matrix? If I write down the definition of a null matrix, also known as zero matrix. So it's very easy to understand that a zero or a null matrix is a matrix is said to be a zero matrix if all elements are 0. So all elements is all. That means including the diagonal elements. So you can say if I replace this, all elements here are 0. So this is 0 again. This is examples of zero matrix. I have taken 2 examples. Over here you can see one is of the order 2 and the other of the order 3. So this is what the number of types of matrices based on. Well, there are other types of matrices also, that is skew symmetric matrix and symmetric matrix, that we will do in the later part of this chapter. So here in this question, we have to write the number of possible matrices. Whatever the number of possible matrices we can frame of the order 2 cross 2 with each entry as 1, 2, and 3. So we have these 1, 2, 3. That is, we have 3 choices over here, and the order is 2 by 2. So in this case, we'll be using this relation that here what we can see that we have a matrix of order 2 by 2 and has 4 entries. Since each entry has 3 choices, that is 1, 2, 3, so the required number of matrices will be what? It should be 3, which is the number of choices multiplied by m into n. So that is 3 raised to the power 4. And how much is 3 raised to the power 4? That is 81. So 81 will be the possible number of matrices that we can frame using these 3 entries of the order 2 by 2. So similarly, we can do this also. We have to find out the number of possible matrices. This time is of order 2 by 3, which each entry has 0 and 1. So what you can see that the number of choices this time we have is 2, and this is m into n is how much? 2 into 3, that is 6. So we can say that the total possible matrices that can be formed is what? That is number of choices that raised to the power m into n. So that is 2 raised to the power 6. And how much it is? 64. So we can say that 64 is the number of possible matrices can be framed using these 2 entries, that is 0 and 1, of the order 2 cross 3. And the next question he says a matrix has 13 elements, then the number of possible order it can have. So if I give you 13 elements, right, 13 elements, and I ask you to arrange, so what you can do, number one, you can arrange like this, keeping one column and 13, one rows and 13 column, as I had made in this, you can see. And second possibility is what? Keeping 13 rows and one column, this one, right? So we can say that there are 1 and 2. These are the two possibilities, right? And there isn't any other way by which we can arrange 13 elements. So there are two possible ways. So we can say if a matrix has 13 elements, then the number of possible order can be 2. So this is the correct answer. Now, similarly, you can do other question like over here. If I give you this question as if a matrix has 5 elements, this time we have 5 elements, then we have to write down the possible orders for this. So you can let me know the answer for this question. Now in this question, it says for a 2 cross 2 matrix and where A is equal to Aij, whose elements are given by Aij as I over j. And what we have to find out is the value of A12. So if I take 2 by 2 matrix, as you can see from here, this is what the first one is A11. The second will be what? A first row, second column. That's what we read. The next is A. This you can see second row and first column. The third one is what? That is second row. The row is 2 and the column is 2. Right. So what we have to find out in this case, we just have to find out the value of A12. Right. So A12, that means here if I replace I with 1 and j with 2, right? That's what it means. The I stands for the row and the j stands for the column. It says is I over j, and I is what? 1 and j is what? 2. So it's going to be half in this case. So we just have to write down half, right? Similarly, we can also fill the other values if they ask for. Now, why not do it? Let's say you can tell me their answers. What should be the value of A11, A11, A21, and A22? Now, here in this question, it says write the elements of a 3 cross 3 matrix and where A is equal to Aij and whose elements are given by Aij is equal to modulus I minus j over 2. Now let's say if I have to fill this, right, that is first row, the element of the first row and first column, what we are going to do? We are going to replace I with 1 and j with 1 in this formula. So it's 1 minus 1 modulus divided by 2. So it comes out to be what? 1 minus 1 is what? 0, 0 divided by 2 is 0. So we can replace this A11 with 0. Now coming to the next. Now using this same formula we can, or the same relation we can find the other values. So let's check for the next one. The next is say A1. I'm going to fill first row and second column. So I stands for the row. So the row over here is I is 1 minus j, which is 2, that divided by 2. Now what is modulus? This is what? Minus 1, right? So minus 1 modulus divided by 2. So modulus of minus 1 is what? 1. So it's 1 over 2. So here we are talking about this. That is, this is a 1, 2. That is first row and second column. So it's going to be half in this case. Check for the next one. Next, I'm going to find this one, the value of this element. So this is first row. As you can see, this is on the first row and the third column. So it's going to be A13, replacing 1 in this case. Sorry, replacing I with 1 and j with 2. Sorry, it's 3, not 2. Modulus that divided by 2 is going to be minus 2 modulus divided by 2, which is 2 over 2. That comes out to be 1. So we can say now this one will be what? This is going to be 1. Now this is 1. Now next, I'll do the other parts. Next, if I fill this one, right, this is what? So over here you can see that here this is a second row. This element is of second row and the first column. So I'll be writing 2 as I and 1 as j. That's modulus sign. 2 minus 1 is 1. 1 modulus is 1. 1 over 2. So we can say the value of this is what? Half. That is 1 over 2. Now the next, this one, this is what? This is on the second row and second column. So clearly here also we'll be replacing I with 2 and j with 2. So that comes out to be 2 minus 2 modulus divided by 2. So that 0 divided by 2 is 0. So this is going to be 0 in this case. Now I'm going to leave this part for you to do, and you can let me know what you got as the answers for the remaining elements to be filled in this case. Similar to the previous question, here the elements of a matrix, 3 cross 3 matrix, are given by Aij is equal to half and then modulus 3i plus j, whole modulus. Now what we have to find out in this case is 3 2. So that means third row and second column. So third row is this and the second column. So that means we have to find the value of this, right? So let me once again tell you, this is A32, right? This is A32. That's whose value we have to find out. So what we can do over here is simply write A32, and in this formula we are going to replace I with what? I is 3 here, right? I with 3, and j is what? J is 2. So that is plus 2 whole modulus. This is half. This is what? Minus 9 plus 2. So this is half, and minus 9 plus 2 is what? Minus 7. So minus 7 whole modulus is 7. So it is 7 over 2. So we'll say that the answer in this case will be replacing this with 7 over 2. That should be the answer in this case.